Welcome back, mathematicians. Tonight we are going to find the product of 7/4 and 2/3. And what we can remember about product is that this means to multiply. So we can multiply 7/4 times 2/3. And what we know is that what this is really asking us, what we can remember is that when we have that multiplication sign, what this really means is we want to know what 7/4 of 2/3. And for those of you that remember, there's another fun way that we can write multiplication. We can show it with a large dot. It's not a decimal. It's a large dot right in between the two fractions. And one thing we can remember is that we have this improper fraction here. And while normally when we multiply fractions, we end up getting a smaller piece because it's saying what's one part of this part or what's two parts of this part, so we end up with a smaller part. But when we multiply by improper fractions, since we're multiplying by something that's larger than a whole, we could potentially end up with a larger piece. So let's try it out. So here we have the same problem, 7/4 of 2/3, or finding the product of 7/4 and 2/3. And the way we can represent this is by using a bar model. So here we have 2/3, and we'll divide our bar into thirds first. And how many parts do we care about? Well, our numerator tells us that. So we're going to shade in 2 out of the 3 parts. So here's 1/3, and here's the second third. Okay, but now what we want to know is we want to know what are 7/4 of these 2/3. Well, our other denominator is 4. So that means we know we want to divide our bar, now using horizontal lines, into fourths. And if we remember, the way we could figure this out is here's 1/4, here would be 2/4, here would be 3/4, and now here's 4/4. Well, we don't want 4/4 or 3/4 or 2/4 or 1/4. We actually want 7/4. What that means is we actually need to draw another bar. Let's do that. And what we want to keep in mind is that these two bars are going to be exactly the same. So we want to divide them first, like we did for our other one, using the same denominator. So we always love to use that. I love to use that second denominator first. So we still want to divide it into thirds. And oops, I'm going to use our original coloring so that it looks exactly the same. So here we are dividing our bar into thirds, and we care about 2 of them. So we're going to shade in 1/3, 2/3, and again, a new bar. So we start again, 1/3, 1/3, 2/3. Okay, but now looking at our other denominator, it's divided into 4 parts. So we need to divide each bar into the same 4 parts. And now if we look at the numerator, we care about 7 of those. So let's see, here's 1/4, 2/4, 3/4, 4/4. So we actually care about all of these. 1, 2, 3, 4, 5, 6, 7, 8. And then that was 1/4, 2/4, 3/4, 4/4. Here's 5/4, 6/4, 7/4. So we actually care about almost all of them. And if we look now to see how many are colored in, let's go back and we'll count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 boxes that have both the green and the red coloring. But the question is, how many boxes did we have in one bar? So you need to be really careful. We're not counting how many boxes we had in both bars all together. We want to know what's our denominator. What did we divide one whole into? Well, we have 3 columns and 4 rows. So that means we have 12ths. So let's make sure. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 12ths. And we should turn this into a mixed number. So 12 goes into 14 one time. Remainder of 2. Our denominator stays the same. We can simplify to 1 1/6. So let's make sure that when we use our algorithm, we still end up with the same answer of 1 1. So let's take a look. 7/4 times 2/3. Well, one thing that we know we love to do is if we can simplify before we multiply. It makes our job a lot easier later on. Well, what's the greatest common factor of 2 and 4? 2. So we can divide both by 2, and 2 divided by 2 is 1, 4 divided by 2 is 2. And if we multiply now, since 7 and 3 don't have a greatest common factor other than 1, we multiply. 7 times 1 is 7. 2 times 3 is 6. We don't want to leave it as an improper fraction unless it asks for it. How many times can 6 go into 7 once? Our remainder is 1/6. So we did end up with the same answer. So we can use an algorithm, we can use models to show how to multiply improper fractions.